Hello, in this video we introduce random variables. So in real life, when we would like to analyze a random experiment, we usually focus on some numerical aspects of that experiment. For example, suppose that you run a company and at the beginning of the year there are some uncertainties about that business. For example, you don't know which products are going to sell better. There are some economic factors that could impact your business and so on. So you can look at the entire business operation as a random experiment. However, there are some numerical aspects of that experiment that you are interested in. At the end of the year, you probably want to look at the sales or your profit in the business. So these are in some sense some numerical aspects that summarize the entire random experiment. These are examples of, in fact, random variables. And we can define a random variable as a real valued variable whose value is determined by an underlying random experiment. So let's look at an example. Suppose that I play the following gambling game. I toss a coin 4 times and then I look at the results. Each time I observe a heads, I win $1, and each time I observe a tails, I lose $1. So in this random experiment, I can define the random variable x as the number of heads minus the number of tails, because that shows how much money I win. So if I want to look at this random experiment, here I have a sample space that consists of 16 outcomes. Heads, 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 that's one possible outcome. Heads, 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 tails, heads, heads, tails, heads, and up to tails, 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 right? There are 16 possible outcomes if you list all the possible outcomes. And now what I am interested in is the number of heads minus the number of tails, and that's my random variable x here. So I can say that my random variable x assigns values to each possible outcome. For example, if this is the outcome, x is going to be what? Number of heads minus number of tails. So there are 4 heads, no tails, so 4 minus 0 is going to be 4. If the outcome is this thing here, then x is going to be 3 minus 1, which is going to be 2, and so on. So we can say a random variable is a function that assigns values, real values, to the outcomes of my random experiment. So we write this is x, a random variable x is a function from the sample space to the set of real numbers. And in fact, this is a more rigorous definition of a random variable. So random variables, here is the mathematical definition. A random variable x is a function from the sample space to the set of real numbers. Because the random variable is a function, we can talk about its range. Remember that the range of a function, right, is a set of all possible values of that function. For example, let's look at this random variable that I defined here, the number of heads minus the number of tails. What are the possible values of x? We can, let's look at the number of heads and the number of tails, and then the random variable x. Now, the number of heads might be 0, in which case the number of tails is going to be 4. We might have 1 heads, 3 tails, 2 heads, 2 tails, 3 heads, 1 tails, and 4 heads, 0 tails. Now, if there are 0 heads, 4 tails, x is going to be 0 minus 4 is going to be minus 4. Then in this case, in the second case, x is going to be minus 2, 1 minus 3, then it's going to be 0, 2, and 4. So this column shows the set of all possible values of x, and in fact, this set is the range of my random variable x. So in this example, range of x is going to be minus 4, minus 2, 0, 2, and 4. So that's the concept of the range of a random variable. And as I said, the range of a random variable x, which we show by range of x or r sub x, is a set of all possible values of x. By the way, I should mention here that we show random variables by capital letters. So x, for example, y, z, w, and things like that. So there are different types of random variables. In particular, there are discrete random variables, and there are continuous random variables, and in fact there is a third category, which is the mixed category of mixed random variables. And we're going to talk about all of these, and we would like to start talking about discrete random variables. A random variable is said to be a discrete random variable if its range is a discrete set. In other words, if its range is a countable set. So let's remember that sets like natural numbers, the set of integers, or the set of rational numbers are countable sets. And the sets that contain intervals, such as the set of all real values between 1 and 2, are uncountable sets. Now, if a set is countable, then if the range of x is countable, then we say that x is a discrete random variable. So remember that when we say a set is countable, it means that we can list all the elements in that set. So if x is countable, if x is a discrete random variable, it means that we can write its range of x. We can list all the elements. The range could be, I don't know, 1, 2, 3, or it could be, in general, we can list it as x1, x2, x3, and so on. So discrete means range of x is countable. It's a countable set. So if I have a discrete random variable, I am probably interested in the probability that x takes a certain value, right? So let's say, for simplicity, I have a random variable x. I have a random variable x whose range is, let's say, natural numbers, right? 1, 2, 3, 4. Now, what do you like to know about this random variable? In particular, you probably are interested to know what is the probability that x is equal to 1, right? What is the probability that x is equal to 2, right? And so on. Now, if I give you all these probabilities, what I have given you, in fact, is the probability mass function. Probability mass function of the random variable x. So probability mass function of the random variable x is in fact a function that tells me what is the probability that x takes a certain value. So if x is a discrete random variable, such that its range is equal to, let's say, x1, x2. Again, because it's a discrete random variable, I can list all the values in the range, x1, x2, x3, and so on. And the probability mass function of x is defined as probability that x is equal to xk. And here is like a formal definition. Let x be a discrete random variable with range x1, x2, x3. Then the function that px, probability that x is equal to xk, is said to be probability mass function. So this is a notation that is very common for probability mass function. The notation is p sub x of xk. So this is a function, so this is the argument of the function. This x here tells me that this is a probability mass function for the random variable x. So if I want to give you the probability mass function for the random variable y, then I have py of, let's say, yk, and so on. So we will look at an example to make sure that we understand this notation. So in fact, the probability mass function gives me everything that I need to know about the probabilistic behavior of my random variable. Another way of saying that sentence is that probability mass function gives me the probability distribution of the random variable x. So if I have a discrete random variable and you are asked to find its probability distribution, you can find its probability mass function. So let's look at an example to make sure that we can work with this probability mass function. Why not we find the probability mass function for the random variable that we defined before? For the example, that we just talked about at the beginning of this video, right? I toss a coin 4 times and define x to be the number of heads minus the number of tails. So here's an example. I toss a coin 4 times and define x as the number of heads minus the number of tails. Okay, now when you are asked to find the probability mass function of a random variable, the first step is always to find its range. We have already found this range. Let's quickly do it again here. So the number of heads, the number of tails. So the number of heads could be either 4, 3, 2, 1, or 0, and the number of tails 0, 1, 2, 3, 4. So in which case x is gonna be 4, 2, 0, minus 2, and minus 4. Okay, so as we saw before, range of x in this example is 4, 2, 0, minus 2, minus 4. So all I need to find is probability that x is equal to these values here, right? K for k in the range of x, right? That's probability mass function, and we show it by px. This thing we show it by px of k. Okay, so what is px of 4? This is probability that my random variable x is equal to 4. Now when is x equals 4? When we have 4 heads and 0 tails. Remember, this is a binomial experiment. I toss a coin n times and I'm interested in the number of heads. So if you remember the binomial formula, the probability that I observe k heads was n choose k, p to the k, 1 minus p to the n minus k, where p is the probability of heads. Okay, so because I didn't mention anything about the coin, it's reasonable to assume that in this example the coin is fair, so p is going to be 1/2. So probability that x is equal to 4 is basically, here my n is also equal to 4, so it's 4 choose 4, p is 1/2 to the 4, 1/2 to the 4 minus 4, and it's simply, this is going to be just 1/2 raised to the power of 4. And similarly you can find px of 2. This is probability that x is equal to 2, which is equal to, well, when x equals 2, when I will have 3 heads and 1 tails. So again, binomial experiment, I toss the coin 4 times. What is the probability that I observe 3 heads? It's 4 choose 3, and again, it's, if you just simplify this, it's become 1/2 to the power of 4. Similarly, px of 0 is going to be probability that x is equal to 0, which is the case that I observe 2 heads, so it's just 4 choose 2, 1/2 to the 4, and px of minus 2 is going to be probability that x is equal to minus 2, which is the probability that I observe 1 heads, 4 choose 1, 1/2 to the 4. And finally, px of minus 4 is probability that x is equal to minus 4, which is the case when I observe 0 heads, and that probability is just simply 1/2 to the power of 4. So I found, in fact, the PMF of x, because I found the probability that x is equal to k for all k's in the range of x. Okay, thank you.